All right. Hello, all. The main agenda of this session is to showcase a project that I've been working on. I have developed an end-to-end AutoML framework using various AutoML libraries and a data orchestration tool known as Orchest. So the current screen is actually displaying the Orchest. Now, just to give you a glimpse about how the end product looks like. So this is how the end product looks like. As you can see, this is the pipeline that I have. Now, I'm calling this as an AutoML rapid prototyping framework. So what I've done here is that I have actually broken down typical machine learning lifecycle into various steps. That is getting dirty data, cleaning the data, and then performing EDA, and then doing various data transformation techniques, and finally machine learning. All right. So this is similar to a Papermill architecture, as you can see, but here we can visually connect Python scripts as well as IPython notebooks. Although the explanation of how this is done is out of scope of this video. So I'll just show you the concept map about the entire architecture. So this is how it looks like. So we'll have raw data. We can have our own data cleaning codes, which we can place in the data orchestration tool, or we can or you can use the automated data cleaning and EDS steps that I have created. And then once the dirty data pass through this, then we get the clean data from this end, and then we can perform train and test it, and finally we can use these libraries PyCaret, Teapot, and FLAML, which is basically from Microsoft, to create various machine learning models on our data. Now the main USP for this is that now in a service based setting, where we focus on winning client deals, we can have an automated workflow in place which takes in the client data as is and gives us a detailed statistical insights and just a moment and statistical insights and best models for the given data. So the main USP of this product would be a rapid prototyping data science framework to win client deals. Now this will help us in various cases. For example, let's say an e-commerce company who want to onboard, who we want to onboard, and we also want to impress them and also beat our competitors. So what we want to do is that we can request a sample of data related to the project that they want us to solve, and then we can pass our data through this automated uh, data science framework or automated machine learning framework. What this will do is this will take the dirty data as is. Okay, let's say this is connected to some kind of database or API, and then it will automatically clean the data and perform machine learning on it. It will yes, and then it will automatically give us detailed statistical insights, including graphs and everything here. And once all the data cleaning is done, it can also give us the best performing model with given our data. Now this will help us in determining the feasibility feasibility of machine learning for for the data that we have given, that they have given, and also it will help us in recommending solutions to the client very quickly. Now, this framework can also be used daily by our associates as a low code, no code machine learning platform from which we can quickly get an understanding about what data transformation is actually suited for our model, and also what all models to try out, so that like lot of research hours is saved, and it will help us in having quicker deliveries. And also there is almost no learning curve for the end user, but if someone wants to develop this kind of orchestration and pipeline, then some learning curve is there, but it's very simple. So as you can see, this is a direct replacement of Airflow, because it's a data orchestration tool. We can actually schedule our DAGs and these pipelines to run. And this can be, as you can see, this is currently hosted on our test server. Actually, I'm a alpha user. I'm testing this tool out for them. But we can actually host this in the AWS or GCP, and then we can just connect our database and make API calls, get unclean data. Okay, and then we can for this step, as you can see, we are getting unclean data, and immediately this get passed to this AutoML complex and AutoML simple. What this will do is, this is the first you can say first line or first step that will give us a machine learning model, like a prototype machine learning model, which is along with the clean data and all the data transformation that it did. So this is one of the first steps. Now after we get some idea from here, like what all data transformation to do, what all data cleaning to do, and what all models to try, what we can do is we can use our auto data, like we can use libraries that can automatically clean the data. I have already configured it here, so the end user doesn't need to doesn't need to spend much time on it. They'll just pass the data as is. Automatically it will clean the data it fits, it deems fit, and then it will give us a detailed HTML report about how the or the like how the data clean data looks like and what are the statistical insights. So let me just show you one of the examples. Just a moment. Yeah, so this is the type of report that we can get. As you can see, detailed report. Let me zoom in a bit. Yeah, as you can see, we will be able to get some detailed report, and all the and like univariate, multivariate analysis, and this and that. We can get a lot of things. We can like test individual. We can like see individual features here. We can see their interaction, correlation, missing values, how everything. So everything will be getting from this particular framework. And then once it is done, then it will automatically take in the data and it will figure out the best model for it. So here I'm using like 4 AutoML libraries. This is basically VIML, okay, and this is using PyCaret, this is using Teapot, and this is the Microsoft FLAML. All right, so as you can, so let me show you what all I am getting out of this. So so the step is very simple. Like we just need to use this framework as is and just connect our data like this. We just need to point in the get unclean data.py where from where to get the data, and that's all. And finally what we will be getting, we'll be getting this report, HTML report that I just showed, containing the EDA. We will be getting a pickle file for the best model. Right now the best model is XGBoost. We will get AutoML pickle file. This will be from the Microsoft AutoML. It might be ensemble models or anything, but so as you can see, like you will be getting 3 or 4 different types of models, and then you can choose the best one out of it. You will also be getting clean version of data, which will be somewhere here. I'm not sure where it is right now, but yes, we will be getting clean version of the data. And also we will be getting, let's see, there should be another one. Yes, we will be getting um, yeah, I think that is all we'll be getting. So total, we will be getting 4 different types of models. Okay, and yes, we will also be getting this teapot exported pipeline, which is basically a code for like we basically a skeleton code that we can use, containing all the data pre-processing steps, best data pre-processing steps, and the best model to be done. So anyhow, teapot is a advanced concept, which will be a part of another video, but just to like brief and just to be on the same page, let me just show you a working example. So as you can see here, what I'm doing is the same. So as you can see, I am using the same framework. I just copied the framework. What I'm doing here is that I'm just making few changes in the code. That is, I'm just pointing it. So there, the first project that that I tested on was actually on tightening data set. Okay, and I have got about like very good accuracy here. But now I am doing on a new data. So here I'm just pointing out the data, right? And let me just show you how it looks like. So this is how it looks like. I am pointing the folder where I am getting this data, credit card data set, and then I'm splitting the data into train and test. And then this orchest.output is basically a connector to the next step. That is this one. So here I'm getting orchest.get input. So when I am actually creating a step like this, let me show you. Let's say when I'm creating a step like this, let's say I mark it as test. Let's say test dot. Okay, let me name this one test dot. Yes, IPython notebook, and then Python 3 kernel. We can also this thing. And what I can do is I can simply just drag and this. So this will basically connect these two notebooks, and I'll just need to mention the output and the input. That's all. Yeah. And as you can see, like let me just go back. Yeah. So I'll just point it to the data, and then it will automatically get passed through the various automated machine learning steps that are there. Let me just show you one of the examples. Let's see about this one, AutoML FLAML by Microsoft. Um, yes, as you can see, let me go down. Yes, as you can see, at the end we are getting this kind of performance metrics, I think, which is pretty good, right? Yeah, so this marks the end of this video. I have also a GitHub repo in place. Just wanted to showcase this to you in video so that you can go through this at your own pace. And if you have, I'm sure like you will have further questions about this. I'll be more than happy to reply. But this is the project that I have been working on, and I think this is a very good addition because, like I mentioned in here, that this is the best for rapid prototyping and winning client deals. So yeah, thank you for your time. Bye.